Hello everyone, Professor Caleb is back with Gus, and today we're going to be solving question 24. I think it's 24. Let me check real quick. Sorry. Yeah, question 24 for the exam 2. And it's funny, I actually already tried this, but I realized I did my math wrong, so I have to re-record the entire thing. So anyway, Gus, let's get started. 20 grams of gas that has the specific heat of 0.205 calories per gram Celsius absorbs heat from its surroundings and undergoes a 25 degrees Celsius increase in temperature. At the same time, an external pressure of 2 atm compresses the gas from 3 liters to 2.7 liters. Okay, guys, let's get started. First of all, it's asking for, I forgot to read the last part. So the last part tells us to calculate the change in internal energy. That's pretty simple. Change in internal energy is delta E equals Q plus W. Right, guys? Pretty simple. And first of all, let's go find the change in heat. So change in heat is pretty simple. It is represented by Q equals M, which is mass, times specific heat, times delta T, changing temperature. Right, that's pretty simple. So look at the part. What does it give us? It gives us 20 grams, 20 G. It also gives us a specific heat of 0.205 calories per grams of Celsius degrees. And it also gives us our change in temperature. We don't know what the starting is, but we just know that it increases by 25 degrees Celsius. So it's going to be times positive 25, because F minus initial gives us delta T, and increase will be bigger than initial. Yeah? Yeah. Anyway, so you might think, well, we have our mass, we have our acidic heat, we have our changing temperature, so why don't we just plug them in, Gus? Well, obviously, because usually we find energy in joules. We usually do acidic heat in joules. And if we do this, we'll find the amount of calories are within. How much heat represents calories? However, we're probably going to want this in joules. So we're going to convert our acidic heat to joules. And what even is a calorie, Gus? That's exactly right. Oh, you did the same thing. Oh, I'll just cut the ad. 1 calorie is equal to, 1 calorie is equivalent to how much energy it takes to raise 1 gram of water by 1 degree Celsius. So in other words, 1 calorie is equal to 4.184. Yeah, basically, 1 calorie is equivalent to. Sorry, it's not my words. Just a second. Oh, forgot my unit. Okay, I got it now. So 1 calorie is equivalent to how much energy it takes to increase the temperature of water by 1 Celsius degrees per 1 gram of water, right? Well, this sounds a lot like acidic heat. I mean, the acidic heat of water in joules is 4.184 joules per gram of Celsius. So we can basically use this to convert that to joules. Sorry for starting a little. I have to think for a second. Anyway, so we write down our acidic heat in. Write that here, sorry. So we'll write it down here. So we write our acidic heat in calories, obviously. So a lot of people walking by now. Let's do this here. No one's walking by. I think I'm weirdo, guys. I guess I am a weirdo. I'm talking to a stuffed animal. Anyway, so we know 1 calorie is equal to 4.184 joules. So 4.184 joules over 1 calorie. And cancels. And we put this in my calculator there. Or my calculator. You're not doing anything, though, so you're just kind of sitting there. Yeah, I need a prop to talk to, so I feel weird talking to the camera. Anyway, This gives us 0.858 joules over grams Celsius. Yep. So let me rewrite this real quick. So our new specific heat is 0.858 joules over grams Celsius. Yep. Meaning it was going to take this many joules to raise the temperature of our gas by 1 degree Celsius per gram of that substance. Sorry to drink, excuse me. Making sure I did everything right real quick, if you don't mind. Yep. Okay, let's go and plug everything in. So we have our mass, we have our heat, we have our change, we have our delta T. So, oh, well, put a dot there. Mine's right another. Yeah, well, make sure you can see everything. Sorry, looks like a maniac. Oh well. Yeah. Anyway, so making sure you can see everything. Sorry. I realize there's a black marker, but it's kind of dead, so I'm using the green marker. And I know it's hard to see from the black one. Try to talk louder. I hope I am talking louder. Anyway, this will give us 20 times. Remember, so the grams from 20, the grams from 20 cancels out the gram from the bottom. And I'm sorry, I forgot to write this. This is Celsius 0. So the change in temperature is 25 degrees Celsius. Forgive me for that. And this cancels out with that on the bottom. Now we're left with is for a unit is joules. So 20 times 8.58 times 25, we get 429 joules. So Q is equal to 429. Yeah. So now it's now we have Q. We need work. Yep. So work is equal to W equals negative P times delta V, where P is pressure. For our case, sorry, let me write it real quick so it's easy to see. Yeah, delta V, and delta V is change in volume. So let's read the work part of the formula again, guys. Oops, sorry, I'm going to apologize. An external pressure of 2.0 atm compresses the gas from 3 liters to 2.7 liters. So let's calculate change in volume. That's really simple. This is where I messed up last time. Very embarrassing. So delta V is equal to V final minus V initial. Our V final is 2.7 minus 3.0. And I messed up, quite embarrassing. I put 2 right there. Simple thing. Sometimes that's all it takes, unfortunately. And this gives us for our delta V is negative 0.03. Yeah? Anyway, moving on. So now we're just going to plug in our numbers. Well, first, yeah, we just plug in our numbers. But to elaborate real quick, when work is being done by the system, that means W is going to be negative. When work is done on the system, it's going to be positive. You see this, obviously, because when you think about it, if work is done by the system, the gas is going to expand. The volume will increase. So if you plug whatever numbers we get into this equation, it'll be like negative P times positive V, which is a negative number, so work will be negative. However, since in this case, since gas is being constrained, the volume is going to be negative. The delta V is going to be negative. So it'll be negative P times negative V, which is going to be a positive number, which means energy is being given to the system. Just need to elaborate that real quick because it's kind of confusing because like it's negative P, but we're going to get a positive number. I know why, obviously. I'm just trying to show you because it kind of threw me off at first, which is why I struggled with this problem at first. Anyway, sorry for ranting. So negative P times delta V, and our P is negative 2.0 ATM times negative 0.3 liters. I forgot my units. I apologize. Yeah, all of our numbers are in liters. Anyway, so 2 times 0.3, or negative 2 times negative 0.3, and we get positive 0.6 ATM times liters. And obvious problem, we want this in joules because it's kind of hard. You can't add two numbers; they have different units. So we need to convert 0.6 ATM liters to joules. Thankfully, Gus, it just so happens to be a direct conversion from liters to joules. So, liters ATM to joules. My bad. So, 1 liter ATM, or you specify 1 liter times ATM is equivalent to 101.325 joules. So, we just use dimensional conversion. So 0.6 ATM times liters. And I know I wrote liters times ATM, it doesn't matter. Same thing. Anyway, so 0.6 ATM times liters. And on bottom will be 1 ATM times liters over 101.325 joules. And this gives us, let me see. I just going faster than this one last time. The last one took 16 minutes to do this. I guess because I did this before. Anyway, so 0.6 ATM times liters, and these cancel out by the way. But we need to say that 0.6 times 101.325 joules, which is, oh, my legs so sore. Gus. Which equals 60 point. Oh. I'm gonna cheat a little. I'd rather have my answer in 2 sig figs. So I'm gonna rewrite 0.6 ATM to 0.60 ATM. So I have 2 sig figs in my answer. So our joules is 61 joules. Yep. Sorry. Is that easy to see? Let me check real quick. Kind of. Let me rewrite it. I'm struggling. Anyway, I'll just say that loud because you can't see. So 0.60 ATM times liters times 101.325 joules over 1 ATM times liters is equivalent to 61 joules. Okay? So W equals 61 joules. And let's finish this off. So we have Q, we have W, now we can find delta E. So 429 joules plus 61 joules. 429, 61, you get 490 equals 490 joules. Sorry, I'm trying to talk loud. Sometimes I kind of mutter. You guys can hear me. Sorry. So our delta E is equal to 490 joules. Or to say, the change in energy is positive 490 joules. So meaning a lot of energy was added to the system. And let me see if y'all can see that real quick. Can you? I'm having trouble reading it. Oh, you read it? Yeah. Sorry. Yeah, you can do that, hopefully. And that's our answer. So, woohoo! Don't forget to like and subscribe for more bonus videos.